now. We are now recording. So thank you, Taras. I will officially introduce you, but welcome on behalf of the OCMA. Thank you for attending the first academic session for this 3-day conference, and thank you all for joining. We remember that you have a conference badge that you can apply for if you attend 5 or more sessions out of the entire 3-day duration. Then you can go back and claim that badge. So if you're interested in that, then please keep that in mind. So Taras has already mentioned, if you have any comments, any questions, you can raise them immediately and he will address them. I will also be monitoring the chat as we go. And there's the option to raise your hand in Zoom. So Taras can always comment on those who are raising their hands as well. Try and keep yourself muted so that there are no background noises that happen during the talk, but I'm very excited to hear about Taras's work that he has gathered for us today. He's going to be talking about mathematics and numeracy in uncertain times. And those of you who don't know him, he is from George Brown College. So welcome, Taras, and thank you. You can take the floor.
All right. And so I wanted to start out with a twisted land acknowledgement, in the sense partly that we're in different places. And which have different histories connected to the first peoples that were here. And so each of us has heard land acknowledgements about the places that they're living in. I wanted to take a little bit of a different approach. And so the pictured are 2 canoes. And so it comes from, a story told by Cadmus Delorme. So he's known because he's the chief of the Cowessess Reserve in Saskatchewan. And so at George Brown, we actually had for, I think it was a day after the Reconciliation Day, he spoke to us collectively. And one of the stories he told, which I thought was really fascinating, was about canoes. So it's a land acknowledgement, but it's on water. And what he spoke about was that, the Cowessess canoe, and so he spoke about his own nation, is in a canoe that's way behind the Canadian canoe. The Canadian canoe is paddling ahead, and then there's this Cowessess canoe that's really far behind. And what he spoke about was the fact that for years, the Canadian canoe was trying to tip over the Cowessess canoe and kind of leave it behind and get rid of it and so on. But the Cowessess canoe is still there. And what he was saying, and it was interesting because it took a different perspective than I think most of us were expecting, is that he did not want, or nobody in Cowessess wants, and it comes from the notion of guilt, right? The sense of feeling guilty and so on. So feeling guilty is not really productive in a sense. And what he said was like, guys, we don't want your canoe to be pulled back to be level with ours. What we want, that would be crazy, he said. You're a G7 country. You're respected around the world and so on and so forth. We don't want you to be back with us. What we want is we want you guys to help us join you at the front as a G7 nation. And so that was kind of an interesting perspective. And I really appreciated hearing that from him. And I wanted to take a moment to kind of recognize that and retell that story as a way of starting what we're doing today. And for us to think about land acknowledgements where we live, and also how math education can be something that is used to keep another canoe back, or to help another canoe come and join ours in the front, or not in the front, but further ahead. And so that's kind of a starting place. So that also came from this another fellow that I'll mention, Edward Doolittle. He's a professor of mathematics at First Nations University in Regina. He's Six Nations. Grew up in the Six Nations, not too far from Hamilton or Toronto. And so he spoke about, I think it was his aunt who was in residential schools, and she felt that the mathematics education was where they really got us. Right. So he expressed that. Now, I thought, I never really thought about that. And so that's one of the things, that the themes I think that is driving what I'm talking about today. So phenomenon one. And I mentioned in the blurb that I'd be kind of bringing together indigenous ways of knowing alongside this post-truth movement phenomenon, so to speak. And so indigenous ways of knowing. So this is a movie. It's a fascinating movie by a German director, Werner Herzog, in 1984. And it's a story of these engineers who want to, mining engineers who want to develop mines, and the Aboriginal activists, you could say, who are say, you can't do that because this is where the green ants dream. And so this whole battle ensues. And so this is kind of a standoff portrayed here in this. I just grabbed this from a trailer, this image. And there's this one, and I'm going to just stop sharing for a sec. There's this one moment where they're in court. So that they have this whole trial, and the lawyer for the mining company is speaking to these Aboriginal gentlemen and asking them, like, okay, so give us like, how far, what are you claiming here? How far, what is yours? Where are the green ants? And the gentleman on the stand just kind of just puts his arm out, and the guy's like, oh God, like right. And so this is this notion of and it crystallizes to me one of the challenges. I'm just going to reshare the screen. The challenges that that we face when we think about indigenous ways of knowing, especially those of us that are very quantitatively oriented. And so that I remember that from the movie. And so now when we're talking about indigenous ways of knowing, I looked back at this slide, found this slide. And so that was one of the things that I just want to put that out there as an idea. So more formally, Gelsa Knijnik or Knijnik, I'm not sure how you pronounce her last name, wrote about ethnomathematics. She studied Brazilian land lists. So again, the connection of land is very important. So we did a land acknowledgement, and I think the struggle to have a say over the land where you live goes back, is not really only for indigenous communities, but also in city areas. And so she studied, I guess, peasants in some ways, you would call them, or in Brazil. And so ethnomathematics, these are things that I've chosen, compels us to analyze the effects of truth produced by the discourses of academic mathematics and school mathematics. So we have, right, so indigenous math and we have school math. So those are the contrasting things. It's gone into, I didn't do that. Next, to consider the centrality of culture and the power relations that institute mathematics education. So again, I've mentioned that with how residential schools were used and how it's not really out in the public, but mathematics education was one of the things that was brought to take the Indian out of the Indian, so to speak. And then problematize the dichotomy between high culture and low culture in mathematics education. So again, so ethnomathematics investigates that and challenges us to think differently and to ask questions of our own mathematics that we're teaching. And I find that very troubling, and I've struggled with those ideas to a great extent. As a mathematics teacher, I was a high school teacher for about 15 years or 12 years before I came to the colleges, and I taught a lot of kids struggling. So in city kids in Toronto, struggling with basic life skills and mathematics, of course. And so Indigenous education, according to Edward Doolittle, in a traditional Indigenous education, people are encouraged to develop their own sophisticated personal responses to situations and natural phenomena. I don't know what that looks like in a mathematics classroom. And what this next statement was really kind of made me sit back a lot. These ways of understanding may actually be supplanted by mathematics education, which is not just mere knowledge, but a Trojan horse full of Greek philosophers wielding logos. So the notion of rationality as a cultural tool of oppression, and that's and I live by rationality, so that I found that a particular challenge as well. So I want to throw that out there as kind of the challenges that we're facing when we're thinking about Indigenous ways of knowing, and bridging that with what we're doing in a math classroom at a college. Closer to home, especially for those of us living in Toronto, where we don't have large Indigenous populations in our classrooms. Now, this guy is actually, he is a, sort of put it bluntly, but he's a shit disturber. So he's an anti-protester. So he's not an anti-vaxxer. He's out there just kind of making fun of them. And so it became so his sister's actually an epidemiologist. So I heard about this through a Twitter. I follow somebody on Twitter that reposted this, because people were just like, who is this guy? Da, 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 da. Anyway, he's kind of making fun of them, but that just goes to show this notion of especially social media, and it predates social media, this notion of playing and irony, and making fun of the other, so to speak. And so this is a particular presentation of this, but one of the things that I wanted, that it challenges me, this post-truth phenomenon, and doing this, and I have a laugh with this guy, is that notion of skepticism that we're all, well, not all, but many of us are brought up with, and that we consider very important. And it's in science as well. And the question is, when does this skepticism go too far? And so this is one of the things. And again, this notion of rationality and challenging authority, so to speak. So in some ways, they're doing a lot of the things that other communities have done as well. So I found our essay, and it's in the, this essay by Vittorio Bufacchi, sorry, I'm not sure if I pronounced that right. It's in under resources. So you can see the essay there, but these are just a few little things I grabbed from there. And one of the things about post-truth is that that makes it a little bit different, is that it's a deliberate strategy aimed at creating an environment where objective facts are less influential, where theoretical frameworks are undermined in order to make it impossible for someone to make a sense of a certain event, phenomenon, or experience, and where scientific truth is delegitimized. But it's the notion of it being a deliberate strategy that makes it very different from Indigenous ways of knowing. It's not a way of knowing. It's a way of delegitimizing, undermining institutions, undermining order, tendency towards chaos, all those things that we know about. But the notion of it being a deliberate strategy is something that I think is important when you think about it. Now, one thing that we don't think about much, those of us, especially in mathematics and science, is the notion of objective facts, and that those objective facts, in some ways, we consent to those. So it's almost an institutional. So in our education system, we've built a consent about these are the important things for people to know and learn. And so this consent theory of truth has existed for a long time. If we really want to define what it means to know something, what does it mean when somebody learns something, and so on, it gets complicated. Once you scratch the surface and keep going, it's like, and so the consent theory of truth, if you want to see a really interesting discussion, check out 2 + 2 = 5 as on Wikipedia. It's fascinating. There's all sorts of historical context, and we've basically consented to agree mathematically that 2 + 2 = 5 is false. Now there are twists. You can go, okay, 2.4 + 2.4 are both 2, or you can do, there's another one where you do 2 squares + 2 squares. If you join them together, they actually become 5 squares because you have the one big one surrounded. So there's all these little twists, but really mathematically we consent, and it only works while we continue to consent. that 2 + 2 = 4. The whole system falls apart otherwise. Phenomena 3. And so this is really important one too. Science and mathematics have moved on. And so our teaching and our institution, educational institution to a great extent, is built around 19th century, maybe some 20th century elements as well, models of reality. So this is from Nassim Nicholas Taleb, who is he's a bit of a, shit disturber in a lot of ways, very strong analytic, data science, statistical skills, understands the mathematics behind it as well. And so he presents this. I don't know why the real world is still in cubic form, but anyway, so he just presents how the real world is and what science can do. But nevertheless, science has bridged the gap in a lot of ways between that simplistic little cube on the right and the real world. And our understanding of reality no longer fits that mode. And we have machines that can do. We just watched the movie about AI AlphaGo and how it beat 4 out of 5, beat a Go master from Korea. So today there are multiple logics, and this is scientific truth. There is no longer classic binarist logic. So that's a real challenge to what we do. The way we teach mathematics is right, wrong, right, wrong. So there's binarist logic. There's a proliferation of intermediate logics. Scientific truth is nowadays much richer than it was 2,000 years ago. And so how do we bring some of that richness into a mathematics classroom in a college is one of the challenges I want to raise there as well. Mathematics, again, and a lot of people say, I don't know, we can't define mathematics and so on, but we know it does not live in the world that surrounds us. It lives in other worlds. It runs ahead of concrete applications by a margin of several centuries. Again, this is Fernando Zalamea, who is a Colombian mathematician who does like really amazing art installations and physical movement installations with mathematics as well. So despite this widely disparate intentions, what my claim is that these phenomena, they threaten the privileged position of math and science in our schools. And we do have a privileged position, okay? That's why people hate math, quote unquote hate math, right? Because they're scared of it, because they realize that it has a power, okay? And then, so also these phenomena provoke fear in us as teachers for the loss of possibilities for rational discourse and for establishing truth. Because the way that we've established it is now being questioned. So the consent is being withdrawn by at least, the ethnomathematics community for sure. And also these post-truthers in some ways are saying, we don't consent to that. We don't buy into your logic. And then for the challenges to how to reimagine how and what we teach in college math class. So that's the nuts and bolts. So we have all this amazing ideas floating around, and what does that mean for our college math class? Enactivism, so I'm looking at the time, 10:24. Enactivism is a theory. So again, I have a link to that. It's a theory that's got a lot of depth that I'm not going to go into, but there's a couple of things, again, I'm pulling out that I think are important for us to help us think about what a college math class would look like. So power is a privilege of not having to listen. Like that is just a profound statement, right? And so as teachers, and we know that, we hear that, if we don't know that from our own classrooms, we hear that about other teachers, they wouldn't listen, right? I had an idea, I had a way of doing it. No, this is the way it's done. And so this power dynamic that we need to acknowledge is there. And sometimes it's not that we as teachers individually bring it in, that we're ready to listen, but the students are already socialized into, well, mathematics class is not where people listen, or not where we have discussions, where I don't have to grant consent. Question of what we know is not distinct from the question of who we are. So again, these are, I think, all profound, thought-provoking ideas. And I don't really know how to bring them into math classroom exactly, but I do want to try. We are unable to provide a satisfactory defense for the mandatory study of mathematics in its present form. So that again this is coming from math educators at the University of Calgary. So Brent Davis is a professor of math education there. And so this is an indictment of math education in the bigger picture that they could not come with. So the idea is that there's a sense that it needs to change. And most of the work is being done at the elementary level. And some work is being done, I think, here and there in the college level as well. But I would like to put out a call that we can do better, we can do more. We who are involved in education are also actively engaged in the transformation of our culture. We must seek a conversing with that which has been handed down. And to make that explicit, what does that mean in I guess, simpler terms is also, so we need to start having conversation. This has been handed down to us. Where has it been coming from? What is it telling us? And what do we do with that? And we're in the process of transforming our culture. And again, we're in uncertain times, and we all feel it, I think, not just because of the pandemic, but it's even pre-pandemic. And so what is it that what kind of conversation can we have with that has been handed down? And it's a challenge. I don't know if there are any questions. Oh, here's a long one. Good.
Yes, mathematics. One just popped up.
I teach the pre-trade, preventing losses of millions of dollars. Correct. Oh, okay. So excellent, because I have a challenge for you coming up with that. And my indictment or their indictment is mathematics in its present form. So the key is not to throw out the baby with the bathwater, so to speak. The key is, so this conversation with what has been handed down. Of course, there are things that are true. There are things that work, and things that science and mathematics has brought. So this is not a broad brush. Let's get rid of math, and I hope I'm not projecting it that way, because that's not my intent at all. So what an activist math proposes, and these four are kind of ones that I've selected. Again, not in the most comprehensive way, I guess, but these are four that jumped out for me. What is not forbidden is allowed. So again, in our classrooms, there are many things that we stop ourselves from doing because, oh, that's just not the way it's done in a math class. Like, well, but hold on, you could do it. They suggest provocations, and I love this term bricolage. I don't know if people know it, but I heard it based on cooking, right? So basically you open your fridge and you kind of look around what's in there and you throw it together and you make a meal. So the end goal is fuzzy at best. And this is the kind of stuff, it's interesting. I have 3 kids and it drives my kids crazy. So they call me Mr. MacGyver, Jimmy, because I'm always playing around trying to make things with what I got. And in mathematics, I think the most fun for me was when I was successfully able to do that. So the end goal was somehow fuzzy. There was some goal, but I was able to grab those mathematical tools and mathematical ideas, play around them, put something together that kind of made sense. That was the most exciting stuff. And so I think that bringing something like that into a classroom, I don't know how to do it in a college 4 months, where you got to get some skills that are going to help them build a bridge, or I teach mostly health science students, and so to help them and make decisions with in uncertainty, and that's a real challenge. And then the notion of assessment as sit beside, that was also really profound for me, and that's what it comes from in Latin. Assidere means to sit beside. So I actually looked up the etymology of that. Errors are not to be remediated, but to be learned from, requiring collective action as much as subjective action. And so going back to that comment, which I really appreciate. So any other comments like that, I really would love to hear or vocalize. So I think that's another way of bringing another perspective, another way of teaching and learning. So the notion of collective action. So if a student is making a mistake, how do we build it into our courses so that it's my responsibility as well as the students? And of course, you're going to have some students, and I know I'm hearing the voices, right? So you're going to have some students that just don't want to play along, and we can't reach everybody, so to speak. But that one I have an approach that kind of I think worked for me anyway. So these are some proposals that they have for getting out of the challenges. This is from Brent Davis.
Taras?
Yes.
There is a hand up from Maxim.
Perfect. Yes.
Hello, Taras and everybody. Hello, how are you? Everything is great. So it's kind of pity that we don't see each other in person. Always enjoy our conversations. But yeah, just to what you said, I think it's relevant a bit. I think, and what I encountered is that there is actually a misunderstanding by non-specialists, right? So we frequently hear that, yes, definitely understanding of foundations of mathematics, of epistemology, all that stuff has changed. And it's great when people enjoy in these kind of, conversations when, basics of math are challenged and so on. But what misunderstanding is about is that we speak about numeracy, right? So the basics of logic, basics of mathematics. And the situation is very similar to Euclidean versus non-Euclidean geometry, right? Let's say a lot of people tell me that, look, you mathematicians, you don't know the truth anyways, because look, you believed that that the world is three-dimensional, and now all of a sudden you say other stuff. It's 11-dimensional in string theory, or it's not even Euclidean. So these conversations are really not true, because, well, in order to understand non-Euclidean, you need to understand Euclidean, right? And it's a starting point. In order for you to challenge mathematical foundations, you need to understand those foundations well at first. And at every slice of reality, regular logic still is there, right? You can push to different types of logic, but in each of the types of logic, and even that meta logic still operates based on primary axioms of logic, right? So when we speak about numeracy, I think a lot of people are running too fast and enjoy conversations and engage in conversations which are too advanced. Speaking about numeracy, I think the most important is still to understand the foundations of regular logic, right? Understand foundations of basic mathematics. And then after people, get accustomed with that, they are welcome to really enjoy more advanced conversations. So a lot of issues that you raised today are valid, and it's just, and it's great when foundations are challenged. It's just when that happens too soon that we have a problem. When it doesn't happen that soon, we actually don't have a problem. We have great philosophical conversations, advances in philosophy of mathematics and even in mathematics itself, but advances only happen after foundations are understood. It's just like my students challenge me that, I don't teach them calculator or Excel in the beginning. I tell them you have to understand the basics first, then move on, but they don't understand why they need to understand the basics, right? It's just only after the fact you kind of understand. I'm sorry, maybe it was too long.
I think
interjection.
These are great. These are great. And so I'm just going to jump ahead to one slide, like way ahead. So this is Conrad Wolfram's suggestion for one way around this. So the notion of abstraction. So once you've defined a question, to abstract it into mathematical form, to mathematize it, that's my sense of what numeracy is trying to get at when people talk about numeracy and numeracy tasks. I personally don't think that numeracy is useful even to talk about if it's all we're talking about is computational skills. Computational skills, of course, are important, but this notion of abstraction, when people talk about numeracy and the struggles with numeracy, they're really talking about the notion of abstraction and then of taking the abstract, turning it back into the concrete. But I'll come back to that, okay?
Yeah, sure. So just for example, that conversation on Wikipedia, 2 + 2 is 5, right? It's a semantic, trick.
The idea is that the idea of that was just that it's a consent. So Wikipedia is one way that one of the representations that we currently have that this notion of consent of truth, because this is a publicly available resource. They have some moderators, but basically people write in and contribute, and those are then become the truths. And it's how many people use it as a source for true information because of the notion of consent. So even something like 2 + 2 = 5, which seems absurd, is discussed. And then you see the historical context, and it's fascinating.
Yeah, no, true. The only thing is that before really taking those considerations as they are, a person should understand what addition is, what a number is.
Correct.
Right? You cannot get excited. A person cannot get excited about these kind of complicated scenarios where 2 + 2 leads to another number before people understand the basics. It's like, if you know Banach-Tarski paradox, when you unite two spheres of the same area, of the same volume, you get a sphere,
right.
One sphere which has the volume of each of them, right? So it's kind of a paradox, but like you can be fascinated about that and tell everybody that you see 1 + 1 is actually 1, right? But you see, you don't. But
it's not. The trick there is, again, separating out the mathematics and the concrete spheres. Well, they're not really concrete, but in a sense, we're treating them as concrete objects. And when you're not actually adding 1 to 1, it's the same thing. There's a video of adding 20 degrees water to 20 degrees water does not make 40 degrees of water. But that's absurd because that's not a quantity in the same way as when we look at 1 + 1
it's always 2. Some trick which is happening, correct, which is replacing what the foundational idea
correct.
is, right?
Correct.
Anyways, I just wanted to say that it's all great discussions about, advances. It's just what people are doing, they are running too fast.
One of the things that I think, so this is this notion of conversing with that which has been handed down is, I think, one thing that I here and there have brought into the classroom when there's been a moment where a student asked a question. So the idea of 0, right? The idea of negative numbers drove mathematicians crazy about 500 years ago. And students don't know that. And so when we bring stuff like that into the classroom, informally, not formally, informally, I think for some students, I've found at least, or I've heard back from some students that they find that fascinating because they have no idea. Their understanding is that this is handed down to them sort of like the 10 Commandments. But when we have this notion that we can have a conversation which what has been handed down. And of course we can go too fast, as Maxim says. And it's a delicate, so it's not a simple thing to bring this in, but I think it's an important thing to bring meaning back to mathematics. So it's not just considered sort of like a religion or a compulsion that you have to do it. And this is the way to have to do it. But that's not the way it was done before. And that's maybe not the way that we'll do it in the future. Anyway, so I'll just shift ahead because I do have a couple of provocations, well, at least one provocation I'm hoping to get you guys involved with. So the notion of assessment is to sit beside. and the notion of errors as requiring collective action as much as subjective action. Those are challenges put to us. And again, they're complex and far away possibly in the future. Now, Edward Doolittle, mathematician. So again, PhD mathematician, so he's no slouch. And so this is what he says. Question I have is whether mathematics is really a requirement for all those trades or whether it is being used as an arbitrary filter. He teaches at First Nations University, by the way, in Regina. Goal of education should be to help increase optionality of our students. And so those of you that have read Nassim Taleb, you'll recognize that term. And so how do we increase optionality? How do we engage students in playing with mathematical ideas in a way that doesn't make the mathematics an arbitrary filter? So of course, there are some things, so Maxime, what you raised, you need to know. And in their different trades, there are different things that you need to know. And so, for example, there's a huge discussion right now, and I think Edward's part of this, is, you know, how calculus is a gatekeeper for so many programs at first-year universities. And we don't have that kind of conversations at colleges. And maybe through what we're doing today, I hope to at least probe that a little bit. And so what I've done is, and I'm going to put, have a link over here. Uh-oh, where's the Jamboard link? Okay, I'll put it in the chat. I can find it elsewhere. So the question, so what I'm asking you is to post a mathematical assessment task.
I put it up for you, Taras.
Oh, that'd be great.
Yep, it's there. And just letting you know, it's 10:42.
I know. I'm seeing that. Okay. So I'd like to post this mathematical task, assessment task, which you would consider arbitrary filter in the program that it's used in. And so I can start off by saying that in health sciences, or you can post it in the chat, because I'm not sure, but I'd love to see a bunch of them in the Jamboard and you to see each other's. And I can share that in a sec. But so I will start off by saying that I teach in a program in health sciences where they have to write a certification exam. And in the certification exam, I know what they have. One of the things they have is to calculate the standard deviation. And I know for a fact that calculating the standard deviation will not help 99% of those students understand what a 99, I'm just throwing that number out, but it will not help students understand what a standard deviation actually is and what it's actually measuring. And that's one of the things where you go, okay, statistics education has been dominated too much by the mathematical underpinnings of it, rather than what we're actually trying to do with the mathematics. So I'm going to open up the Jamboard and I'll put the screen up to see if we have anybody. So the first page there is just for you guys to play and put something up, just if you've never used the Jamboard. And then each page, subsequent page, so has health sciences, arbitrary filter that you would have. And if you want to share one by posting it in the chat, then feel free to do that as well. If you're not comfortable with the Jamboard. I'm not seeing any so far. Those pages are done. Does anybody want to share any thoughts about okay, so norms. Yeah, that's classic. So the context, because again, mathematics, when you're working with mathematics and mathematical tasks, one builds on the other. And so you develop an understanding of Euclidean geometry, and it's a very systematic thing. With numeracy, when we're the context tells us what mathematics we may need to solve those problems and whether we have enough mathematics. So a lot of mathematicians, their work is actually, they work side by side with biologists. Biology now is a huge one. I heard about stuff with viruses, right? And so they study and they build mathematics that's going to help solve problems with how viruses propagate. But do people have people, again, I'm not getting much back, and it's hard to, and I don't have your faces, and we're not in the same room. Does this make sense that there are arbitrary filters and that we are using them to a great extent? I think that's an important thing to acknowledge. Okay, so I'm just going to skip ahead and authentically messy tasks. So this is, again, so I threw this slide up with Maxim's question, and the notion, so this is, again, Jordan Ellenberg, and so I've posted, I posted a name his book called How Not to Be Wrong, and I've talked about this before. And so he looks at how mathematicians solve quote unquote real world problems and how messy those are. And the notion of, I think for us in the college sector, and so Norm brought that up, with how certain math challenges or numeracy challenges, I would prefer to call them numeracy tasks or numeracy challenges, are relevant only to particular programs of study. They don't make sense in another one. So if you're asking about something like future value, but you're not in a business program, or you're not studying accounting or whatever, that's the context, the framing of the question is the issue. And so the mathematical idea is maybe understood, but the way the question is framed is going to make things difficult. And so Jordan Ellenberg says dividing one number by another is mere computation. Figuring out what you should divide by what is mathematics. I would change that a little bit and say that's what numeracy is. So when Maxim's talking about, it's a great book, isn't it? It's a real fantastic book. Just inspirational and exciting. And when Maxim, you talk about mathematics, like a lot of what you're going, yeah, that's so cool, right? And it's something about, there's this thinking that mathematicians can bring, good mathematicians bring to problems that other people may not bring. And it's not only the sophistication of the mathematics, there's something else. And I think Conrad Wolfram, who is kind of self-promoter and so on, but his notion here of the abstracting process, that is, I think, one of the keys that I've just come across. So again, this talk is what you've been inspired by over COVID time. So there's a talk he gave at Adults Learning Mathematics. They had a few days where we could listen into people speaking. That's where I heard Gelsa Kniznik as well. And so the notion of abstraction, going from the concrete to the mathematical and then back. And so those points are which we're not so good at, and I'll speak for myself, I'm not so good at and have not been for the past 25 or whatever, 30 years of teaching, have not been really good at, or at least I don't do it explicitly, maybe implicitly or somehow I fluked it. So I call it collateral learning. Students learned that from another way, but I think we need to make that explicit. So this is also called, so Conrad Wolfram calls it computational thinking, because to put it into computable form for a computer to do for us, to do the hard work of computation for us, that's the challenge. But we can call it also mathematical thinking, which is what Jordan Ellenberg, and there's Keith Devlin, and there's others who call that mathematical thinking. And then in some parts of the world, it's called quantitative reasoning, and sometimes it's called numeracy. I think that's where numeracy resides. So I think doing numeracy as math light, as the stuff that people need, that's, I think, not a useful approach, because that keeps us back on this notion of numeracy as calculations. And that's one of the essential employability skills. So if anybody, I want to kind of do a movement to change that essential employability skill of numeracy as well. So college math education. So this is a little bit of a provocation. I don't think, and again, this is my experience of it to a great degree, is not really about mathematics. we're not developing student understanding of mathematics and developing their mathematical chops, so to speak. That doesn't mean there's no mathematics there. That means that it's not about mathematics. The key word is aboutness, right? It's stuck with the idea that numeracy is math light. We're stuck with that, and we got to unstick ourselves. It's siloed, right? Most of us, and again, I shouldn't say most of us, math educators, industry experts don't really take the time, spend the time to develop authentically messy tasks. Oh, by the way, the authentically messy task I referred to here is very simplistic. Which is cheaper? Ask which would you buy and why, and accept answers. So I do this as a kind of formative assessment where I throw in, 2 cans of tuna. One is this size, the other is a different size. They have different prices and so on. And I am totally comfortable with accepting an answer to students say, you know what? I would just walk up and buy the bigger can every time because that's how much I need to eat. That is a perfectly valid answer in a numeracy to that question. And it's because it has to do with quantitative thinking. I like the bigger can. Done. We don't need any calculations. We don't need any fancy math. You don't need to tell me which one's cheaper. Most people do not shop by checking, the price per gram. That is just not the way the real concrete world works. I don't anyway. And I don't think I make inferences about everybody else based on myself. Anyway, so the notion that we don't have the time and don't make the time to develop these authentically messy tasks that are relevant to the programs, the disciplines that we're preparing our students for in the colleges. So I know that for health sciences, that doesn't work. And I know that the certification exam that they have, the mathematics and the statistics that they have there are not, I know they're not authentic. And I know they have not been developed with those in mind. Oh, there's new standards coming up, we'll see. So this is what I've done in my class at a time, 1052. Okay. Mastery-based approach, I already talked about this. Diversity in mathematics assignment is fantastic. You can read this later. Playful nature of classroom interaction. So I totally happy to accept students saying, I don't care, I just buy the bigger can of tuna. Lessons don't always end in a neatly packaged bow. I focus on quantification abstraction process. I'm going to stop there because I would love to hear some questions. And I invite you, please, to let's build a repository of authentically messy tasks, numeracy tasks in different disciplines. Let's start working through these things in our mathematics education. So I'm going to stop there. I went too long.
Thank you, Taras. That was great. As usual, your talks are always very thought-provoking. So yeah, I would like to open the floor for people who would have some comments or questions for Taras. I know we have 7 minutes until the next speaker, but I will stay here. And Taras, if you're available, stay until all those questions.
Oh, yeah, for sure.
Great.
Please challenge. Yes, Julian, yes.
Hi, Taras. Kind of what you're talking about here is just revamping, not just math education, but education in general, almost completely revamping it, right? To start with authentically messy tasks and teach students how to tackle those, something like that.
Fermi. So you heard of Fermi problems, right?
Yeah. And so I guess what I'm saying is, of course, this is something that we need to do and that we'll work toward, but you have to be very patient. These things won't change overnight, and just, keep calling for it, be very patient, and the change will slowly roll out.
Well, thank you. I guess he's saying I sound impatient. But I kind of am. I kind of am because I should have done this when I was 25 or 30. I should have started this. And
Did you know?
I taught in an inner city school where the student, and I was going, why the hell are we inflicting this algebra stuff on these students. That's not what they need. But I didn't know, or I didn't feel that I could do other stuff, right? I did take students into libraries and we did read about math history a little bit now, but that's not the same as like looking for authentically messy problems for them to do that they would thrive in, and that would kind of generate an interest and then get through to the algebra that way. Because I'm not against algebra. It's powerful. Anybody else, please, please, please?
So I had a comment, Taras. I'm teaching more the stat side of things. I do teach the math, but I have to think about the math to really get back to you on the questions you've posed today. So for statistics, I was thinking about the arbitrary filter, and I was typing something and I just couldn't get it into words, I guess. I feel as though, just like Maxim was saying, we need that like foundation to be able to really teach anything beyond that. So I know in my course, I need to teach them a unit on probability. And then that kind of builds onto probability distributions and then hypothesis testing. And this is something that my students will definitely come across in the future. I mean, I don't see probability, like when they learn it, they're like, well, I'm not going to go gambling. Why do I need to know about dice and the probability of rolling a 6 type of thing? And I completely agree. But how do you get around from teaching, like using those arbitrary filters when it's like a skill that's required to be able to move on?
So for probability, one of the things, so I threw that out before, where find a number between these two small numbers. So 0.05 and 0.17. Students have a really hard time with that. That's that's a filter for me. That's not an arbitrary filter. If you're going to understand probability, you have to be able to look at a small number and know that one's smaller than that one, or there's another, right? Now, the probability, I've now separated out the games probabilities from concrete world problem. Like, so when you're looking at risk, that's a probability. Mm-hmm. So in health sciences, it's that link, I think, is easy to make. But how is that calculated? Well, then you got to get into the whole research.
Yeah.
Right? Like vaccine, right? What does vaccine efficacy actually mean?
Yeah. Yeah.
Like, holy crap. To really understand that, that's just a number that's thrown out. The general population is like,
yeah, exactly.
I guess so. But what is it? You have to understand the experimental method, right? You have to understand a clinical trial, what they do for that. And but then they don't even report the confidence intervals. Yeah. So you're like, well, yeah, 94%, but what's like, and it's like, whoa, it's complicated. Hard things are hard. And I think that thinking with data is really hard.
Yeah. So before I kind of let you go off, we do have 2 minutes. So I realize that some attendees will end up going over to the next presentation. But yeah, we're staying here. So feel free to continue on this discussion. So I do see some hands. So I think you can choose who you'd like to talk to next.
I thought, Sandra, you had your hand up, I think, earlier.
Yes, thank you. Well, I love the analogy that you have about the fridge when you open the door and you need to a meal. I love that image because it really represents what the problem is. But if you ask that question, for example, a little kid who has no idea how to cook or what is an egg or the many different ways to cook an egg, they will not be able to ever prepare a meal. They will just grab milk and drink it, or you need to know what you can do and the possibilities of every single ingredient that you have at fridge in order to prepare a meal. I think that is the problem, that we will love to show a meal preparation, but how, if they have no clue, right?
And so they have to have an understanding of, each is salty,
basic thing. Yeah.
Vegetables are not those different.
Exactly. Yeah.
And same thing with mathematics, right? You have to have, people talk about number sense. Mm-hmm. You have number sense, then you're able to play around with right? The idea of a quantity, three, three books, right?
Yeah.
Is different from the number 3 being written. That's an abstraction.
When I ask my students to prepare, to write a setup, and they say, let's X be the white ribbons. Not the number of white ribbons. It's just so important, the difference, right?
And that's why I think Conrad Wolfram's that computational thinking algorithm, so to speak, is really useful, because it helped me anyway think about when I set problems, and I can zero in with students when I'm trying to quote unquote listen to their and help them through their solution. I'm like, okay, that's where you're struggling with. You don't know what that means.
Yes, exactly.
And so Monica, going back to yours, when they see when probability, when I do this stuff with normal distribution, probability that X is greater than 35, whatever, and the mean is 17 and the standard deviation is 8 or whatever. They got to figure out that. Well, they don't understand what that means. They just see this abstract stuff and they're like, oh, I got to do some calculations and come up with a number. But that thinking about what you're cooking, right? The bricolage is like, okay, I got these things, but what am I doing with this? I've lost track. I have this broccoli here, but I've lost whole track of what this thing is or what I.
Overcome this now. Online is even worse. So have them in a classroom and we can just chat on the moment, on the go, as you say, assessment. You are sitting beside them, right? But now online is so much harder, right? To see those issues and to just address those little details. I'm writing emails for hours, right? Trying to explain, no, this is the difference. This is what you did wrong in this little step. But
so with mastery,
I can do this. Right?
So the interesting thing with mastery-based learning on that is that students need to achieve 80% in order to have that concept count as success. So they succeeded, mastered it. When they don't, I make sure they talk to me. And then I listen, I ask probing questions. Did you understand the meaning of the question? Like, well, depending on their situation. So I listen for them. And you know what happens a lot of times? Students go, you know what, I looked at it after I submitted and I was like, oh, what a stupid, I just didn't read that part of the question. Then if they're close, I go, you know what? Okay, you got it mastered. I listen to them. Now I'm making them redo the whole thing because I listen to where them talk about where their issue is. But like cripes, if you have 200 students in your classroom, you can't do that with every single one. So I do it with the ones, especially that are close to mastery. Then the ones who are far from mastery, I have a conversation going, what's happening? Why are you totally off? Like, what, can you tell me what's going on? And oftentimes I'll hear back things like, well, I got a kid, I had a, student, I mean, she was traveling somewhere with her family this year, online teaching, right? She's like away for 4 weeks. Oh, I've been like, geez. So you listen and you get a whole different sense of what they're struggling with. And it's like, okay, so you get the math stuff? Yeah, I get it. I'll do it better next time. Okay, fine. So it's interesting. Like
I love it. Yeah. Thank you so much for the other side of the things. I love it, the other point of view. Yeah, good.
Norm, you have a question?
Well, I just wanted to share something you were saying about not having the time for 200 students. And for the last 20 years, most of my courses, at least the last 16 of them, I stopped lecturing and I create videos of all my lectures. And when we went distance learning, like I stopped lecturing in class and I would just give them quizzes to get them thinking. Well, now showing up for my Zoom meetings is optional. It's only if you need me for something. And what happens is most of them interacting with the videos and the quizzes and everything and don't need me. So I've got the time to spend with the students that need my full attention, and I got to say this distance learning model is better than the classroom model because, when they were all in the classroom, if I was trying to give one student attention, it disrupted the others that were there. But now the ones that don't need me don't show up. The ones that do need me do show up and get specialized attention.
That's and So you have 200, you said?
I got 119
Yeah,
and 40.
that's great.
So
Yeah, that's a survival. You got to survive, right?
no, but it's honestly not like my video lectures have integrated quizzes and everything that get them thinking and interacting. They only show up when they have a problem they can't solve on their own, right? And so honestly, out of the 100 and well, what does that work out to? 159 students, I think. My classes generally have 5 or 6 kids show up, you know, and I just deal with them one-on-one, and they leave happy, and it's just working out great. And I've automated all the assessment, well, practically all. I mean, so I do teach an electrical CAD course, which I've got to do the drawings manually, but everything else. So you know, I come from industry where mining industry originally, where we do a lot of time study, method study, work study, and we look at ineffective time in a person's achievement of tasks, right? And so I've applied that to education, where assessment in itself, you need assessment data, but the time spent generating it is ineffective time totally. So if you can automate all that stuff, you free up time to actually mentor and teach, which is really where the value is in having us there, right? The value isn't in me crunching numbers and coming up with an analysis of how you're doing. It's getting those numbers generated automatically and then just dealing with the problems.
And in that context, I mean, sounds great.
Yeah, it's working for me and my students. They like it, so.
Okay,
so Monica says that we're
gonna have to stop, but this is great. This is amazing.
Thank you.
Yeah, so much to think about, definitely. So I do encourage you, reach out to Taras if you'd like to continue this discussion, and I'm gonna stop the recording.